Most of our electricity is generated by heating water and turning it into high-pressure steam, which spins turbines, creating mechanical energy that is converted into electrical energy by generators. However, these systems require a lot of parts, space, and ongoing maintenance. Dr. Austin Lowe, Chief Research Officer at GenAlpha Nuclear Technologies, is developing a new, compact system called SpaceTech that converts nuclear radiation into electricity without any moving parts. Such a system would open up a huge range of new applications for nuclear energy, not least as a power source for the spacecraft of the future. SpaceTech is based on thermionic energy conversion, or TEC, a process that involves heating up a special emitter metal to very high temperatures, causing it to release electrons. These electrons then travel across a very small gap to a collector metal, creating an electrical current. However, most TEC systems are limited by the space charge effect, which causes electrons to build up around the surface of the emitter, creating an electric field that blocks any further electrons from being emitted. Most systems counteract this effect using a low-temperature plasma that aids the flow of electrons from emitter to collector. Unfortunately, creating a plasma in this system uses up energy from the emitted electrons, meaning less energy is available to convert into electricity. As a result, current TEC systems have a typical efficiency of below 7% and have few applications beyond research laboratories. To reduce these inefficiencies, SpaceTech uses a number of innovative solutions, including using nuclear radiation to heat the emitter and to create the plasma without using energy from the emitted electrons. Higher gas pressures within the SpaceTech system create an environment in which this nuclear radiation naturally creates the low-temperature plasma needed to conduct the electrons, meaning more energy is available to be received by the collector. SpaceTech also uses specialized metal foams as the emitter and collector. These highly porous metal sponges are full of tiny holes and channels that give them a huge overall surface area, meaning there are more places for electrons to escape from the emitter and to be collected at the collector. Thanks to these innovations, SpaceTech could be used to create nuclear power plants that are quick and easy to construct and transport. Not only could these smaller, simpler, cheaper power plants help us transition away from dirty fossil fuels, but they could also revolutionize space travel. In space, it's ideal to have a lightweight, compact power source with no moving parts that might need ongoing maintenance. SpaceTech could therefore be the ideal system to power future space stations, rovers, or even settlements on the Moon or Mars. What could you achieve as a nuclear engineer?